So this isn't quite what I had planned. I was in the middle of getting all my equipment set up to do a different video, and I got it all ready. I thought I was going to start filming last night, and then I thought, yeah, I'm going to get a good night of sleep, start in the morning, fresh, film this video. So I get up, I start turning on my equipment. Of course, right now, oh, there it goes. Yeah. So my function generator greeted me with that terrible noise this morning. So it has this one dumb little cooling fan. I don't know why a signal generator needs a cooling fan, but apparently they decided they needed one, and now it's failed. So as a temporary distraction from the next video I was working on, this will be a miniature teardown/repair of the Protek B8010FD function generator. This is a pretty basic 10 megahertz function generator that'll make all your usual sine waves, square waves, and so on. And it also has some nice modulation features, and it can make pulse trains. I don't know if I would actually recommend getting this model, though. It hasn't really aged well. As you can see, the front panel's gotten quite yellowed. The buttons on the front were originally coated with a sort of soft touch rubber that started deteriorating and getting gummy after a while. I've already taken some isopropyl alcohol to this thing a couple of times to clean off most of the gummy residue, but I think I might have to give these buttons a more thorough cleaning when I have it open. So as far as I can tell, all the screws are on the back. The case seems to come apart in two halves, top and bottom, and it seems like the front comes off separately. And it's possible they would have hid some screws under this stick-on label, or under the feet. If we're super lucky, I just have to pop this screw out and then maybe the top cover slides out. I don't know. I don't think it's quite that easy. I think I might have unintentionally made myself a warranty void sticker. Sorry, little scanlime. That was probably necessary, but not sufficient. Seems like there might be a snap right there. If I were designing this, I'd probably need a snap right there to hold it together. No screws under the feet. The rubber feet come off easily and don't go back on easily. Nope. Yeah. That, I hope, didn't break anything. Yeah, it looks like this is just put together with one screw and a bunch of obnoxious snaps. Looks like this case might actually be designed to slide apart in some way that wasn't quite working for me. Like if this could just slide backwards after taking that screw out, but that didn't seem to work. Like maybe this has to come out first. So it looks like you have to tilt the handle to the right angle and then pull it out. Any more luck with sliding it off? I mean, the problem at this point isn't getting it open. I'm just trying not to break any of the snaps so that I can put it back together. And without really knowing how this is supposed to come apart, it takes some care not to break the plastic snaps. So with this ridge, I thought there might be a way for this top to just slide back, but that doesn't seem to be working. But maybe it's designed so that this part bends outward, and then you can kind of get it over that ridge. That seems effective. There's some more snaps near the front and on the top. That seems like there might be something under there. Oops. No. Oh, this thing is terrible. Dope. I'm not entirely sure what happened there, but I think I might have spilled glue on the case right there. And so that was actually fused together with a drop of spilled super glue or something. And now, oh well. Alright, this thing is super weird inside. I'm not totally sure what they were thinking with this foil on top. This back panel is painted. I don't see any place for it to actually make electrical contact. And this foil doesn't seem to have any pressure marks, like it's actually making contact with anything. So I don't know if this actually is going to help at all with EMI. So right away, this thing seems like kind of a time travel accident. Like, just such a weird combination of technologies from different eras. So this board was manufactured, possibly even designed, in 2007. But if you look at it, this does not look like technology from 2007. So some of this is kind of unsurprisingly retro. So, it has a linear power supply, which you don't see so much anymore, but for a piece of lab equipment, linear power supplies actually are still kind of common, so that's not too big a deal. So for some reason, these people decided that even though they were manufacturing this circuit board in 2007, that it was still a good idea to use all of these through-hole resistors and capacitors and transistors and these ancient socketed PLCC chips and socketed dip parts. There's some more... there's some more socketed dips on the back side of this front panel. Like, super bizarre. Yeah, more socketed parts down here, all covered in stickers. I'm curious what this lone surface mount chip is among the sea of old school dip. This one little hand soldered chip, a U34 there. That top line is the date code. And then that bottom line has been partially blacked out with Sharpie. While it looks like that marker was only covering up a couple of digits. Some kind of variant of the 74HC14 hex inverter, perhaps? But I don't know why we don't see the 74 prefix, why it just starts AHC14. Alright, this side seems to be where the real surface mount goodies are hidden. Well, that looks like our main output D to A converter. And I'm guessing this is some nice fast SRAM that holds the output waveform. This is going to be a parallel bus of samples that get clocked out to this DAC at probably around 100 megahertz. Let's see if we can find a datasheet for this DAC. Here's the datasheet for that D to A converter. It's a pretty speedy part. To get a good sine wave at 10 megahertz, this would have to be outputting digital samples around an order of magnitude faster. So in this case, the D to A converter is rated to run at up to 125 megahertz. They probably have memory here that runs at about the same speed. This looks like a very old school design that just never got optimized for modern components. You just would never design something like this in 2007. This would be something that is kind of an old design that they'd been kind of maintaining just a little bit at a time over the years. As one part goes obsolete, they replace it with something else and respin the board, but they never bother actually redesigning the thing. So zooming out again, let's just get our bearings on this entire board. Obviously our power transformer over here, and this is a kind of classic linear power supply with multiple output voltages, multiple regulators. Old school, low noise, simple, but it throws off some heat, so you've got some heat sinks. This is the microcontroller, and this looks like it's probably some kind of really old school multiple chipset design where maybe they have, like, I'm guessing that U5 here is probably the microcontroller itself, and these Oki Data chips with the quality control sticker on them are probably, like, maybe this was originally designed for EEPROM, and then they've retrofitted this design with flash memory, perhaps. Then all of these PLCC chips, I'm guessing these are actually pretty old school programmable logic of some sort that's being used to interface the microcontroller with the actual kind of fast digital sampling engine over here. This is going to be some kind of digital logic contraption that creates a really fast path between the D to A converter and a fast chunk of memory, but then also provides a way of loading that memory with patterns that are either stored in read-only memory somewhere or generated on the fly by the microcontroller. So these chips in the old school PLCC sockets, they might be programmable logic that forms part of that machinery, or maybe these are just memory chips that hold waveforms or program data. There are a lot of just little bits of discrete analog and digital logic here. Here's a 74 LS164, 74 LS245. I think that's like a bus transceiver. This looks like a fancy op amp over here. We've got an 808055A op amp. So after the D to A converter, now we have this kind of analog domain signal path that's probably mostly concerned with kind of mapping this to the right voltage range. This has a configurable output voltage where you can set where the center of the waveform is and where the peak voltages are. So this probably has a slower set of D to A converters that set offset voltages and gains and that sort of thing. The labels would imply that there are 5 relays. Yeah, here we go, 5 relays. 1, 2, 3, 4, 5. So these 3 relays are next to resistor divider networks that are labeled as 1/64th, 1/16th, and 1/4. So these are going to be output attenuators, I assume. Wow, this resistor has some burn marks, actually. So I think these 2 transistors with the big heat sinks would be the kind of main output stage for this thing. This is the sort of amplifier you would design to provide kind of a very accurate output over a wide voltage range, but not necessarily any power efficiency. So I'm guessing these 2 transistors form kind of a push-pull amplifier that works sort of like a linear voltage regulator, but much faster, in order to create a regulated output at a frequency up to 10 megahertz. So I think this resistor is probably in series with the actual output of the instrument. And so if the output was driving a fairly high power load, or if it was shorted, then this resistor might have gotten warm. Yeah, this is probably the series termination resistor. It's 50 ohms. Seems like it's still fine. Yep, this leg of the resistor goes straight to the output BNC jack on the instrument. And then this leg, I'm presuming, goes to both of these transistors. Oh, is this also shared with the attenuators? Oh, yeah. Okay. So this resistor isn't just a series termination resistor, it's also part of this attenuation network. So when these transistors are pumping out a high voltage signal and you have the gain turned down, then really it's just dumping most of the power into this little resistor. Poor guy. So I'm starting to see why maybe they needed a fan in this thing. So I'm curious about all these digital parts that they have stickers covering up. Just to get ourselves a clear view, I'm going to unplug this connector, which seems to go to the LCD on the front panel. Yeah, this is even labeled eLCD. Don't know what the E stands for. Maybe it's an electronic LCD. Jeez. Well, that's no good. The ground lug on this IEC input is just not even going anywhere. That's just not okay. This instrument has a metal back panel here, and they didn't even bother wiring the ground on their power input to that back panel. You see that lug right there is ground. Nothing. And this isn't one of those fancy sockets that has an internal connection to the screws. I checked those. There's just no ground here. They do have a fuse, so this bus on the left here is running down to the built-in fuse socket. But you can see it also gets very nearby to that serial port ribbon cable. So that's kind of nerve-wracking. So yeah, that's just not really cool. All the signal grounds here are just floating with respect to earth ground. Meh. Let's go ahead and get this fan out. Oh, there's the culprit. Hongfei good quality DC fan. Well, not so much. 5 volt, unfortunately. I don't know if I have any of those handy, so maybe we'll take a stab at repairing this one. So I'm curious what they have to hide under all of these obscure labels. And I don't know who Matrix is. I guess presumably that's whoever actually designed this thing that's being marketed by Protek. Let's also take off that serial cable. Get that out of the way. So I got my sight set on U5 first. My guess is that this is the actual processor. Partly because it's kind of nestled in between what's probably the program memory and either ROM or peripherals over here. It's also right next to this 40 megahertz oscillator and the LCD connector. So this would be a great place for a microcontroller. Is this sanded? Man, why do people even do this? So it's like whoever these Matrix folks were probably sold this other company some kit of parts. And they're like, if you put this together just right, it'll be a function generator. But you can't look inside. And so they decided this was a good idea, maybe? It's probably an 8051 or something cheesy like that. Maybe it's a PIC. I don't know. If we really cared that much, we could probably figure out what kind of processor this is just by looking at common processor pinouts and seeing where like the power and the crystal are. Oh, let's see about these memory chips here. All right, these are both identical. Presumably it's two 8-bit halves of a 16 bus or something like that. It's a 82C54A. 82C54A is also a hex color according to the internet. All right, coming up empty looking for data on these two chips. I'm guessing it's some kind of flash memory or possibly one-time programmable ROM. Oh, no luck with any of these chips. And that's frustrating. I mean, I'm sure that if anybody really wanted to figure this out, it wouldn't be too hard to deduce what these chips were and reverse engineer what's going on. If anybody even wanted to bother reverse engineering such an ancient design. In this case, it just means it's not really worth our trouble to learn from it right now, which is unfortunate. Yeah, these capacitors seem a little bit bulgy. That's not too worrying, but if I had any spares that were a perfect fit, I'd probably replace these. Alright, let's try repairing this fan. Well, I've got the fan running off of 5 volts right now, and I don't really hear the same kind of terrible buzzing from earlier. I wonder what's up with that. So the fan does work. It's drawing a little bit more than the rated current, about 220 milliamps. But it seems like it's mostly fine. So, some kilohertz. I should be able to type in 1000 kilohertz. Great. The number pad feels so much better now that I cleaned it. This is a pretty decent function generator. You know, it isn't the speediest thing ever. So it can generate a pretty nice looking square wave at a couple megahertz. But if you start to approach the upper limit of 10 megahertz, it starts looking really rounded off. Here it is at 10 megahertz trying to output a square wave, and really it's barely distinguishable from a sine wave. Of course, to generate a really good looking 10 megahertz square wave, you'd probably need something with around 50 megahertz of analog bandwidth. So let's try a sine wave and see how that looks. The sine wave looks reasonably alright, although we're getting a decent amount of jagginess. I don't know if this is just general noise in the system or if this is related to the sampling rate. My guess is that the sampling rate is exactly 100 megahertz because there's a 100 megahertz crystal right here. Well, the fan's still going strong. If the many design WTFs on the board, the fan seems to be powered through a series resistor. Like maybe they wanted it to be a little bit less loud or something. So it's getting 4.2 volts instead of 5 volts. So whatever. Well, there's our clock rate. So those jaggies, when I touch the clock, there's tons of interference caused by the kind of low quality grounding I'm using for this test setup. So ignore the jaggies you get when I'm actually touching this, but do notice the actual frequency of the clock. And then when I'm not touching the clock, this is just the regular quality of the output on here. So that jagginess is either internal crosstalk between the digital logic and the analog output, or that's just noise caused by the sampling at this high output frequency relative to the sampling frequency. Well, there's the sampling clock. That does seem to be fixed at 100 megahertz. Yep, with the 100 kilohertz output, we still have a 100 megahertz clock going into the D to A converter. When you zoom out this much, that larger sine wave is actually the clock frequency aliasing with the kind of horizontal decimation frequency of the scope or something like that. Well, I hope you enjoyed that miniature teardown and repair video. This isn't the most awesome function generator out there, but it's not too bad. And it's sort of a weird, interesting design to take a look at. And after a quick cleaning and taking it apart, put it back together, then it should serve me well for a bunch more years. See you next time.